This is meant to be a short introductory lecture to vibrations and why vibrations are important to study and to provide context for the kinds of vibrations one could study. In this course, of course, we'll be focused on a very narrow uh, special case of vibrations, which is single degree of freedom linear vibrations, which we will talk about um, very soon. But this video is just meant to provide sort of general context and motivation for the kind of interesting phenomena that vibrations might entail. Okay, so what do we mean by vibrations? It's a type of dynamic behavior, some kind of movement in which the system oscillates about some equilibrium point, perhaps. Um, some kind of oscillatory motion is what you would call vibration. Um, it could actually be more complicated than this definition entails. This is just meant to be a very rough, crude definition. Why study vibrations? Vibrations might cause discomfort. Vibrations can act as excitation for sound and noise. In fact, sound and noise are vibrations, as you may know. Can be good or bad. Vibrations can be good in certain situations, but can also be bad in other situations. Good kind of vibrations could be music, for instance. Um, Bad could be earthquakes shaking a house, for instance. Okay, um, so bad vibrations could potentially cause large stresses in machinery, can cause catastrophic failures because of that, or persistent vibrations over a very very long period of time can cause fatigue um, driven failures. And you may have seen this video, this very classic video that gets shown in lots of engineering introductory engineering classes of the Tacoma Narrows Bridge failure from 1940. So these are wind-induced vibrations uh, induced by wind blowing crosswise across this bridge, and it set up this oscillatory motion of the bridge. Let me fast forward a little bit, and then as you can see here, the bridge eventually collapses due to these super large oscillations. Okay, thankfully, no human was injured, I think, in this disaster. Okay, so for instance, we would like to understand oscillations like this and maybe think of ways to prevent oscillations like this. Uh, just as an aside on this particular oscillation, people sometimes refer to this particular example, the Tacoma Narrows Bridge, as an example of what's called resonance, quote unquote resonance. Um, Modern scientific understanding of this vibration says that it's not classical resonance. So resonance is something that we will study in this particular course, but it turns out that this particular vibration or oscillation is not quite captured by that. It's captured by a different nonlinear phenomenon, which has to do with the nature of wind-induced forces. Okay, so that's that. Here's actually an example of what we would call resonance, which is something that we will study in this course, where uh, there is in this case, a helicopter with a um, spinning blades, and presumably the blades have some unbalanced mass, and that induces vibration of the whole structure. And when the vibration of the whole structure when the structure is vibrated at a particular frequency, it causes very large vibrations and um, results in catastrophic damage, I guess. Okay, so that's an example of resonance, which again, like I said, we will study in this course. Here's an example that we will not study in this course in any detail. I think if you watch the MATLAB lectures, I briefly talk about this. It's a double pendulum, which is a 2 degree of freedom mechanical system. And you can watch the whole video, which you can find by typing in Strogatz double pendulum on YouTube and watch the whole video, or you can watch my MATLAB lecture where I discuss this sort of in the middle of the MATLAB lecture, the third MATLAB lecture. But what I really want to show um, very briefly is if you But a much more interesting thing to do is to start a solution in the if you uh, start off the double pendulum with some small initial conditions, that it sort of oscillates like that. But then if you start off with these larger angles and let go, you notice that the motion is incredibly complicated. Okay. Um, it seems superficially unpredictable and rather complicated and non-periodic. You can call this also a kind of oscillatory motion, but it would be a non-periodic oscillation. Um, and you should watch the whole video. But this, I just want to show this to show that um, even slightly more complicated systems like the double pendulum can have incredibly complicated dynamics, oscillatory dynamics, and which is something that you can sort of discover either by experiment or by numerical simulation, say in MATLAB, like we did in the MATLAB lectures. Okay. But it's less amenable to sort of complete solution with pencil and paper. Okay, so that's a double pendulum. We will not be discussing that in this course. And then here are a couple of random examples. Um, so a few years ago, someone invented um, uh, a microphone that is based on videos. Okay, so the idea is that if you have a video of some object, and if you make a um, fine enough video with high enough resolution, you can see how much that object vibrates in the video, and from which you can recover the sound that is actually making that object vibrate, sound in the surroundings of that object that makes the object vibrate. So you can actually use a video, a high definition video of an object as a microphone. Um, so I think they invented this essentially high definition video camera, which is looking at a piece of potato chip wrapper. And by just looking at the potato chip wrapper with this high definition, high speed video, you can infer what someone is saying in this room without actually hearing it, quote unquote. Okay, so that's an interesting example of sort of vibration theory that was invented a few years ago. This is just a random fun example of vibrations. This is a real bridge in Pennsylvania, a couple of hours from Philadelphia. This is, I guess, the fun kind of vibrations as opposed to the catastrophic kind of vibrations in the Tacoma Narrows Bridge. So depending on how you excite the bridge, you notice that the bridge will oscillate in different modes. So this is again a many degree of freedom problem where the bridge can oscillate or vibrate in a variety of different ways. So it's not something that we will consider in this course. So which is something to take a quick look at. So they're exciting the bridge in a very particular coordinated manner to do these kinds of interesting excitations. Okay, so those are the videos that I wanted to quickly play to provide some general context for the kind of vibrations one could study. But like we said, we're going to study the most simple versions of these kinds of vibrations.